Thank you so much, Peter, for taking out time, especially the work you have done with Gemini. The extensions of Gemini reaching 1.8 million active users, it's incredible. A lot of people are changing how they want to study computer science. It has been heavily dominated by data structures, algorithms. A lot of things are evolving. They're not able to figure out what to focus on and how, there's big hype of prompt engineering job at Google, which got the biggest hype in 2023, stating 300K and with basically no degree requirements. That's a big hype at Google. We really want to talk about that. First of all, can you share what's up with Gemini? How's everything going?
Yeah, it's really exciting right now. So extensions was, let's say, that was about a year or so ago, and then right now we're doing this push into the so-called agentive, right? And the agentive is kind of exciting because that's really Gemini unleashed, where Gemini can act on your behalf in the world, and let's say just crazy things like banking or communication, or I did this demo the other day where we literally had sort of Gemini agents creating podcasts or day trading or playing multi-agent games or whatever. So in some sense, that feels like a real kind of evolution in the whole LLM space. LLMs able to act in the world, right, on your behalf. And anyway, I think for some reason that's going to be the next big push. But it's a little bit crazy in some sense. Do you trust an LLM to bank on your behalf, necessarily? I mean, it's a little bit weird. Or let's say, next time you go to the doctor, do you trust an LLM as your sort of nurse triage? Anyway, just things are getting a little bit, or do you trust an LLM to parse this, 300-page contract or legal, anyway. So I think all those are going to be interesting things, coming up.
Incredible. I use Gemini the most. I have always my Pixel phone in my pocket, and it has been very useful with YouTube podcasts I watch, and it just gives me the context I need immediately. And now there has been a significant push in refocusing on the skills you should prioritize in your college. What would you tell all the students who were heavily focused in data structures and algorithms to get into Google? Their dream job is to get into Google. How things are evolving for the skills you should target to be an engineer or a prompt engineer?
Oh yeah, that's such a fantastic question. I mean, because there's this funny phenomenon where even after the advent of calculators, people still learned basically how to add, subtract, divide, multiply. And I think in some sense, even after the advent of LLMs, just in terms of self-discipline, it's probably good to know your data structures, right? Because the funny thing is, even to prompt the model correctly and even to program, to have a conversation with Gemini, let's say, about programming, in some sense you have to have a mental model for a lot of these data structures to know what to ask. And I'm just thinking sometimes when I'm programming and I'm talking with Gemini, there's a sense in which I have an intuition for what maybe the answer looks like, and so I can prompt Gemini in certain ways to get sort of, I feel the best outcome. So still study those sorts of things. But I had this phenomenon, this was recently, where I had to select an intern over the summer, and there were thousands of interns to look at. And I remember, I went through all of the profiles, and the ones which stood out to me were really the students that had active GitHub accounts. So sometimes they were linked to these projects that they'd done, and maybe they just did a little bit of prompt engineering or some other maybe sophisticated but the fact that they had these GitHub projects or whatever, that to me for some reason spoke a lot. And so I think in addition to just the fundamental computer science, have active projects, let's say, where, maybe you're scratching your own itch with some, I don't know, LLM related thing, and you decide to create a little LangChain, solution. Just basically active projects are really, I feel what sets people apart now, maybe.
What else do you see in 20-year-old engineers who want to be prompt engineer at Google or a good engineer at the level that you are, to be at the level you are?
I mean, the funny thing is, so prompt engineer, I don't know if we have any prompt engineers on my team. I'm trying to think. I think somehow, we have ML engineers and we have software engineers who happen to also do prompting or whatever, right? And so, and like I said, there's this funny thing, let's say you're creating an extension or an agent or something like that. In order to create one effectively, in order to be able, because here's a funny thing about so-called prompt engineering, is that there's a mental model of the LLM that you have to have in order to do it effectively. And just to give you an example, I did a project a few weeks ago with multi-agent games, and so I just wanted I wanted Gemini to play some basic game against itself. I chose rock paper scissors because it just happened to be the most simple game that requires something like a theory of mind. And I wanted to test this hypothesis about whether Gemini could create something like a theory of mind, basically some opponent that models the opponent's mind in order to like beat it at rock, paper, scissors. Anyway, in order to do all that in a so-called attention-preserving way, like I had to have an intuition for, like there's a phenomenon I know that sometimes where when people start prompt engineering, the prompts become incredibly complicated. In other words, there's a long series of do's and don'ts and whatever. And I notice it's easy to sort of exhaust the attention span, so to speak, of the LLM. And so to know that, the attention span of the LLM is a finite resource, to know how to preserve it, to know how to decompose like really complicated processes into like sort of like sub-prompts or whatever, all that I think requires a little bit of, just a little mental model for how the LLM works. And another example we did was like, so I had this day trader, for instance, that was just kind of like, it was Gemini, like I threw $1,000 at it and Gemini was making trades on my behalf. But in order to successfully do that, I had to decompose this day trading problem into a bunch of different sub-problems. Namely, I had an agent who was sort of like, let's say, scouring the entire universe of purchase of tradable stocks and coming up with a short list of things that, let's say, some secondary agent would look at when it sort of like actually looks at financial metrics and that sort of thing. And then there was a third agent who figured out, okay, of the sort of tradable stocks, of the ones that we're actually looking at, like how much are we going to buy or sort of sell? And so in some sense, like, in order to come up with that decomposition of the problem, like I just had to have a mental model for how much, let's say, the LLM could take. And so that's kind of a roundabout way to say that even for effective prompt engineering, I think you have to have a little bit of a mental model for how the model works and maybe how the infrastructure works. So maybe you have to have a little bit of computer science, to kind of to do it effectively.
Incredible. And I think a lot of startups are working with AI, building agents, and I think cost is a very big thing, very big thing for them. They want to cut down the cost as much as possible. And to cut down the cost, you need to cut down how much you charge per token. If we can reduce the number of tokens, you pay less for that LLM. So what ways you use at Google to make it more cost effective?
I mean, one of the things is just to use the smallest possible model that you can get away with, right? So there's this funny thing going on right now where we're sort of pushing towards these larger and larger models. Maybe we're sort of pushing for something like AGI. But it turns out I don't know if these super large, super expensive models are necessary for every single problem. And so what I notice a lot of startups doing is they'll essentially have this heterogeneous stack, so to speak, where they have a bunch of baby models. Maybe these are 2 billion parameter LLMs, like essentially doing sort of one subtask really well. Like, just to give you an example, there was some startup I was talking to that did like, they were like a hotel concierge, let's say. And so somebody would come in with some query like, oh, I need to change, I need to book, whatever. There were just some baby LLM which just did a classification on their query which said, this person coming in probably wants to make a reservation or change the reservation. And so in theory, you can use like the big model for that sort of thing, but if you can get away with a really small, cheap model, that's one way to save a lot of money. And in fact, what's crazy is a lot of these like, really small, once you decompose the problem, it may be the case that you can actually get away with like classical machine learning. It may be the case that for some of these classification things, maybe you don't even need an LLM, which is crazy, right? And so I think part of what it is people think, okay, I'm going to go with the big model, but it turns out that maybe, by the way, you end up using the big, expensive models as almost a last resort, like almost the cherry on top when you need to generate like a final response for the user. Because the point where you generate the final response, that's where you want to have like this bedside manner. That's where basically you need, maybe some fluency, some personality or whatever. But yeah, I think, basically using the smallest possible model you can get away with is like.
Yeah, incredible. I think the TPUs in Pixel also is a great example of how small models help us. And what do you see the energy what do you think about the energy consumption with these small models? Because it has been predicted the amount of data centers and the amount of GPUs we need in data centers, that could be as equivalent as 5 gigawatts. That is same as powering New York City. So that's the level of energy we need, and data centers are pulling directly from nuclear plants. What do you see the future when small models
Oh,
are being
that's
used.
interesting. That's interesting. And by the way, and I don't know if this is a popular opinion, but I hope LLMs finally push us towards nuclear power. But that's, so I feel like somehow it's a greenest power, dude. Maybe I'm wrong. But anyway, but just in terms of the phone usage, yeah, I think basically a couple things will happen. So I think it'll force us to make sort of probably more powerful, energy efficient chips, but at the same time more efficient models, right? And it turns out, somebody did an experiment a while back where essentially they had I forget what it was. They had one of these models who essentially was just dealing with kind of like an LLM dealing with just Boolean algebra. And anyway, there's a bunch of really creative ways to essentially like quantize a model to bring it down to the point where, let's say, maybe you can do more with a couple billion parameters. Maybe you can do as much with 2 billion as you could have done with like 70, right? And you see something like that. So I think more efficient models, more efficient chips, I think basically will happen. And the nice thing is that I think LLMs also benefit from things like Moore's law, right? Where processes keep getting more powerful. But the other thing that I've noticed too is that even if you have a TPU and a GPU, those sort of chips are still relatively generic. And there may be the sort of thing where, like currently, all LLMs run with these transformer models. And it could be eventually that something will come after the transformer. But assuming that the transformer is what we have right now, why not just literally embed the transformer in silicon and sort of call it a day? Like, in other words, maybe it's a case that the GPU is still a little bit unnecessarily general. And if you have something like a transformer running in silicon embedded in the phone, maybe that ends up actually being more efficient, energy-wise and whatever. So I wonder if we'll start seeing things like that, maybe.
Yeah, and like for those who wants to, like who are now, if if SLMs, small language models, and these hardwares getting smaller and more efficient is the future, what would you tell all the 18-year-old and 20-year-old who are starting their journey in India, US? How would you suggest them what they can build in AI right now?
Yeah. No, that's a really interesting question. And so I had a meeting a couple weeks ago just with some of our like top, phone developers, and what they were trying to figure out is, so just to give an example, somebody had an app which so what he wanted to do was sort of parse all of your documents that exist on the phone. And he wanted to have a database of things you could ask about, all the PDFs, whatever on your phone. And he was saying that basically if you ended up shipping all this stuff to the cloud, first of all, like maybe you can get away with that in sort of like internet-rich countries where, like, let's say, shipping a few gigs to the cloud, maybe you don't think about it. But in some of these developing countries where like you're bandwidth constrained, like just forget about it, first of all. But even just the act of like shipping, let's say, all of your PDFs like up to the cloud, like whatever that is, like some people might actually be wary of that. However, he said that for whatever reason, the processor on the phones, the sort of the LLMs that he can run on most phones, still not powerful enough to really do the kind of questions he wanted. And so it's one of those, I feel like we're in a little bit of an awkward transition period where the sort of on-device models are still developing, but it's still, so it's sort of like we're almost, like shipping to the cloud is almost deprecated, but I feel like the on-device models are not quite ready. So somehow we're still in this awkward thing. But if students want to be ready for what's ever coming, probably within a couple of years or whatever, they should probably try to figure out what they can do with the chips on the phone, the models on the phone, and then hopefully, in a year or two, essentially once we're able to run more sophisticated models, they'll be there. In other words, right? So maybe even though it's slightly ahead of the curve, it's probably not too early to start kind of playing around with what you can do on the device. Because I think at some point that's going to be, you're probably going to get most of the work done on the device, and then really only call out to the cloud when absolutely necessary. You have some sophisticated problem that can't be done on the phone, but I have a feeling that'll become like increasingly unnecessary, right? So. But like I said, I feel like we're in this awkward transition period, where processors on the phones are still sort of catching up, right? But because frankly, actually, I don't know what the statistics on this are. I don't know actually how many people have an Android with a TPU, but I suspect it's a minority, right?
True.
Yeah.
So we shouldn't wait like for these TPUs to get smaller and models to get better. We should just build right away what we have.
Yeah.
But the problem that comes, which I see with YC doing a third-year batch today, and with
Yeah.
all the AI startups that they are incubating, I see that like lot of startups with just adding small features. For example, let's say Gemini, when it did not have the history, just adding one history feature and
Right.
making a startup out of it. And with these small startups, do you see potential with what people are building? Just a small wrapper above,
Yeah.
above LLMs.
Oh, that's so interesting. So yeah, it's funny. Maybe in some sense there are some startups that are nimble enough to play the cat and mouse game, because let's say for every update of the model, let's say every update of the model kills a bunch of wrapper startups. If somehow you're a little bit ahead of the curve and you come up with the next wrapper, like maybe you can keep playing that cat and mouse game for a while. But you're right. So some of these sort of trivial modifications are like a little bit vulnerable. And just to give you an example, like this startup I was talking to even a few months ago that was doing this hotel concierge thing, eventually they closed shop because I think they weren't really doing anything that couldn't be replicated relatively easily by, let's say, Gemini or GPT. And so in those cases, I think those companies are a little bit vulnerable. On the other hand, it's incredibly difficult to carve out a niche that's not like trivially kind of replicable. However, one of the things I noticed, though, and these are a lot of, so by the way, I run this kind of bi-weekly Gemini meetup, and we have a lot of startups that come in. And one of the things I notice these startups are doing, or interested in, are things which are in like medical, financial, and like legal domains. And the funny thing is, for big companies, I think financial, legal, medical, those are they're like kind of radioactive, because it's a sense that like there's so much liability in there. So it could be, for like a startup that has the guts or whatever, it's possible that they can do something in those domains that's not easily replicable by Google or OpenAI, just because they don't want to sort of take the risk. And the downside is that you probably run the risk. Who knows? You run the risk of getting sued or whatever. But maybe it's possible if you take on one of these so-called radioactive domains. Maybe you have a little bit of a moat, in some sense. Maybe a little bit of a protection, just because the big guys will anyway.
Can you repeat finance, health?
Yeah, and like basically anything around legal, health, and finance or whatever.
Legal.
Those things are like, and I think that includes things like, let's say, even things like using an LLM to parse or write insurance contracts, or, so I notice with the medical stuff, there's this funny thing, because people are sort of flirting with the medical in the sense that for whatever reason, using an LLM as like a triage nurse is acceptable, in the sense that you come with some complex of symptoms, you have a conversation, and the LLM basically directs you to like the correct specialist.
Mm-hmm.
What I haven't seen yet, and probably I don't know if this is ever going to come, is you come at the LLM, you're having a conversation. Maybe the LLM literally takes a picture of you. Maybe the LLM has your labs, and the LLM like makes a diagnosis. Like let's say, I don't know when and if that'll ever happen. I have a feeling. I don't know if that'll ever happen in the States, or maybe it's like who knows? Maybe it's like decades away. But I wonder if that's one of the things where almost you need to go outside of the States to like innovate, and then maybe once the FDA catches up, then you come back in like in like 2034 or whatever.
Wow.
But anyway, I noticed that, like, ironically, this financial, medical, legal thing, those are the three things that people seem to be interested in the most. And and by the way, maybe there is a huge potential there, because getting paralegals or lawyers to parse documents, actually probably incredibly expensive. I don't, and so maybe if it's the sort of thing where the LLM can do a bunch of pre-work, even draft things, maybe there's some value there.
True. I think FDA would not allow, or the legal issues would not, the regulations here would not allow that to happen fast.
Yeah.
But outside US, maybe in India or other countries,
Yeah.
if they have the potential, if they do something in health,
Yeah.
finance, or legal
Right.
legal businesses, it can be a big,
A huge thing.
huge mode.
And by the way, somebody did a thought experiment recently, which I thought was interesting. And let's say you characterize this in terms of sigmas. Like, let's say a human doctor is correct. Maybe I'm just saying like 99.9% of the time. And so maybe they're one sigma. Let's say you have an LLM, which is like 3 or 4 sigmas. They're correct like 99.999% of the time or whatever. Even if you have a situation like that, would it be acceptable to have like an LLM doctor? Would the FDA allow it? And my intuition is, even then, probably not. Like, I think probably it would take some time to catch up. So you're right. I think maybe we'll see some innovation outside of the States, and then eventually we'll sort of catch up. But anyway, it like if a startup has the means and if they have the guts to do so, like maybe those are 3 interesting things.
Yeah. Now, my next concern that people have is there is a significant increase in synthetic data. I went to India recently, and
Yeah.
the moment you enter, you see all AI generated images.
Interesting.
Ad campaigns are being done using AI generated images, even in New York City.
Wow.
You see so many AI generated images, and it
Yeah.
brings it brings a lot of attention, and people think it's cool. And at the same time, when you read comments, when you read emails, you can figure out
Yeah.
this is AI generated. What do you
Yeah.
think about this increase?
Oh, what's a little bit weird is that I think there's like a Gen AI fatigue, right, in the sense, and I was talking to somebody about this the other day, even if I'm on Luma or one of these sites or LinkedIn, and if I sense that something is like Gen AI, like let's say, and I'm guilty of this too, but let's say for my meetup, I have like an AI generated banner or whatever. In some sense, I almost perceive that now like a hole in the page. It's almost like there's something there, and I don't even bother looking at it. And I don't know what that is exactly. I don't know if it's because like they didn't, I don't know if it's because for a lot of these cases it's like a low effort product, like they literally put a prompt, they call it a day. I mean, I think it's possible. I think it is possible probably to do some sort of high effort Gen AI thing, which is beautiful and whatever. But a lot of these low effort things are almost like indistinguishable from noise. And then the funny thing on LinkedIn too, like even before I read a post, if I look at the length of the post, even the length of the post is sort of a signal that this thing was possibly like AI generated. I kind of, in some sense, don't even bother to read it anymore, right? And I was telling somebody the other day, this was crazy to me. I got an email from Sundar the other day, okay, and because I was asking him if he wanted to come to this event in New York, and I got this fantastic like one-line email that was ostensibly not AI generated in the sense that it was like I don't know, it didn't have like flawless punctuation. It was like straight to the point. It looked like Sundar or like somebody had written this thing or whatever. And in some sense, I was saying that was like actually really refreshing, because one of the things is when you get these long like AI generated emails or introductions, it's just so anyway. So I think we're at this weird thing where people joke that generative AI is almost like write only, in the sense that everybody wants to generate this stuff, but I don't know if people really want to consume it, right? Mm-hmm. And that's this weird thing. And I wonder if there's a future in which if you have human-generated artifacts, and this is sort of like, I don't know, writing, or this is art, or this is music, I wonder in some sense if those things will be like fetched like a higher premium because they're sort of like artisan or something, or like there's a human in the loop. And yeah, and I just, anyway, it'll just be interesting to see where this Gen AI fatigue goes. And one of the things I'm really curious about, because I have a bunch of kids growing up in this, my kids are going to be inundated with all of this like Gen AI stuff constantly. And I wonder how the next generation is going to cope with that. Are they going to rebel in some sense against like Gen AI, or is the Gen AI going to become so good that it's like indistinguishable from human output? Like I mean, do you have an intuition about that actually? I mean, what's your sense, man?
I mean, I think software engineers get really scared when they put a prompt and they see like, oh, it's so good that I am just doing copy paste work.
yeah.
It brings a lot of fear, and
Yeah,
when they see when Amazon leaked that they want to like
yeah.
literally finish off all the software engineers in 2 years,
Oh,
they get
yeah.
scared.
Yeah, yeah.
And who have just started their career, spend 4 years into studying it,
Right.
they get a lot of fear. And also the fatigue you're talking about is there. Like
Yeah.
I don't want to read with the email which completely is like headings and context written. It's like completely obviously AI generated.
Yeah.
And I think we need I think some supervision. Without that, when you can easily predict that this is 100% AI, people will be tired. They want to see new stuff every time, creative stuff every time,
Right.
and which is hard with AI.
Yeah. It's true. I mean, some people were theorizing that Gen AI would get so good that it would be indistinguishable from human. But even now, it's still like, I used to call it like LLM smell. There's still like these interesting signals. And it's true that you can prompt the LLM in some sense, and you can say, by the way, write with bad grammar, by the way, short sentences or whatever. But still, like somehow, I don't know if it hits the mark. But yeah, that's going to be an interesting one. But here's a funny thing, though, in terms of like the code writing thing you were talking about. I mean, I'm not sure what other engineers' experience is, but I noticed that if I naively prompt the LLM in some sort of coding thing, like usually what I get, like some of the time it's usable, some of the time it's not. And this intuition about like whether or not this thing is usable and how it can be changed to be usable, like that sort of intuition still requires some like a little bit of an engineering or some kind of engineering intuition. And so I wonder if that will ever go away to a certain extent. I wonder if it's totally possible. Like there was some project, like I think it was Devon was one of these projects, but there were some of these projects which aimed to replace the SWE like in a full stack way, like literally taking, going from like GitHub issue all the way to like pull request or whatever without an engineer in the loop. And I think they have some of these corpora, some of these test sets, and I think even Devon at the time, it was only scoring like 30% on some test set for like these kind of SWE, like, so anyway, anyway, it'll just be interesting to see how that plays out. And I have this hypothesis, and I don't know if this will be right, but I just have a feeling that humans somehow are co-evolving with the LLMs. And I think if it's true that the LLMs can free us from some of these mundane problems, it's possible that we can start to think about sort of bigger things and more interesting things. Mm-hmm. And if that's the case, maybe there's still some hope for engineers, because basically, and by the way, I think that's related to this. Have you heard of like this 2030 event horizon or whatever?
No, I have not.
So, I mean, there's this thing, and this is like 2030, basically, they estimate that LLMs will have been trained on the entire corpus of like human output, right? So basically, literally everything, the entire internet, every single book, all the code, let's say. And so at some point at 2030-ish, we cross this event horizon where LLMs have been trained on literally the entire human corpus. And the question is like, what happens at that point? I mean, do we keep creating new things, or does like humanity basically retire and kind of LLMs take over? And anyway, it'll just be kind of interesting to see how that plays out. But yeah, I think you're right. Somehow engineers are like in the trenches, and yeah, it's almost like, like we're the first hit in some sense. You're right.
Yeah. I think engineers have to be cognitive of the fact that things can change. No career has a guarantee of being staying in the next few years, and just listening to predictions will make no sense. Just focusing on, as you mentioned, data structures are still important. They should focus on it.
Right.
Like we still learn reading English, we still learn grammar, we still learn that. Even though ChatGPT can do that for us, we still learn that in school. I think that would never change. But we can spend our time focusing on bigger problems.
Yeah.
Absolutely.
But also, I wonder if there's some sense in which it'll change the way we learn. And like, did you study computer science, or did
yes,
you?
I did. I did.
So I don't know about you, but for me, it was like this was like pre-LLMs. It was a lot of me wrestling with textbooks or whatever, right? And the funny thing about learning with an LLM, it's like you have this tutor and there's this conversational flow, and you work with somebody. Maybe, by the way, students will just have a different way of learning, and by the way, that may be really interesting, right? And it'll be, I'm just really curious to see, where this will go.
Totally.
And,
And now a little bit about, I wanted to talk about security. Like we have time, right? So like there are a lot of cases with prompt injection. How do you at Google? How do you code in a way and think about security? Because there was a case with Chevrolet when someone prompt injected, "Give me a free car" somehow with invisible HTML or somehow, and Chevy had to give a free car as per Twitter. But what do you think about prompt injection and security's role in AI?
The funny thing about LLMs, and I guess as engineers, we're used to having like a compiler and all these really like deterministic in a command line or whatever. And I think I told you I had this thing with Gemini where Gemini was playing multi-agent games, and in this rock paper scissors case, it was Ares versus Athena, and I gave Ares these really strict sort of heuristics. You start with rock, and when you win you switch, and when you win you stay, when you lose you switch. And despite that, during the course of the game, at some point Ares said, "You know what? I'm going to go do my own thing. Like, thanks for your suggestions or whatever. I'm going to find my own heuristics. Like, thank you very much." And so the weird thing about the LLMs is, everything is sort of prophylactic, and you can't really command an LLM. It's like you can suggest sort of that they do something, and there's various tricks you can employ. But I think that's going to be a cat and mouse game. Like, for instance, I mean, we, like a lot of companies, hire people whose sole job is to literally red team, their models and whatever. So I think that's going to be an interesting cat and mouse game. But here's the other thing. I think, however, a bunch of people are probably going to go to open source models with no restrictions. Like, that's just my sense. And, I know a lot of startups already run on like a Llama 3 stack. But I just have a feeling that, you know, in some sense the world will bifurcate. Here's sort of the safe LLMs, and then here's a kind of Wild West of LLMs. And I think on the quote unquote safety side, I think this is always going to be a cat mouse game, and it's going to be some mixture of, like, you know, special models that actually do some kind of threat analysis and whatever, and some mixture of prompt engineering. But yeah, this is always going to be an interesting cat mouse game. But what I'm waiting to see is how many people end up going to open source models just because they don't want to deal with, like, safety filters, right? That's going to be interesting.
So true. I mean, there are bounties, opportunity up to $15,000 for a lot of these, you know, AI models, and I think that's going to be the future because it costs so much more if there is a security breach in a model. I think last I would like to touch on, like, what are the principles you follow at Google which have made you smarter engineer?
Yeah, that's an interesting one. There's no substitute for just being surrounded by people who are smarter than you are. Unfortunately, that's the way it is, man. And if you're surrounded by people who are smarter than you are, then hopefully a little bit of that rubs off by osmosis. But practically speaking, you know, some of the things which Google's been doing for like decades now at this point, which are like the code reviews, and we have the code reviews and the readability reviews. I think all those help you asymptotically sort of become a better engineer. But what I do find is a little bit interesting is, let's say, cases where engineers would get together and, like, almost in extreme programming fashion, like, let's say, like the famous cases like Jeff and Sanjay or whatever, like Jeff and Sanjay would get together, they would hack together, and they come up with like MapReduce or whatever, right? Craziness. And now I notice that other, like, pair programmer now is typically like the LLM, and so it'll be interesting to see how that evolves. You know, like, I wonder will that affect people's relationships at all? Will it mean that, you know, as an engineer, you don't have well, we'll just see how that kind of thing. Like, if the LLM ends up becoming like your favorite pair programmer, we'll see how that goes. But yeah, somehow I you know, being surrounded by smart people is kind of humbling and amazing. You know.
And yeah, I think there's like more hindrance to calling your friend or colleague now because we have so many tools. And when you ask your colleague for pair programming session, you kind of get like, am I dumb kind of a question that I'm not able to figure out myself.
That's true,
But I think we need to get over that, and like pair programming has brought, you know, the innovation has only happened when people come together, and that has to come, right?
Yeah. No, that's great. So, Hunter, I really appreciate your time. Thank you so much for coming over to Google. It's been great. I really
Absolutely. Thank you so much, Peter. Learned a lot from you, and it helps a lot of students who are, you know, kind of figuring out what to learn in college. Thank you so much.
Thank you so
Absolutely.
much.
Pleasure.
All right.